This video is primarily made for enthusiasts of vintage hi-fi gear. And if you're a vintage gear person, then servicing and repairing goes hand in hand with ownership. And Jim, who's done all of the servicing of my gear over the past 4 years or so, is a fun guy to deal with, and we've become great friends. In this episode, I asked him to go through the process that he employs to diagnose and repair faulty electronics. And the whole video shoot was over 2 hours long, and I've edited it down to what I judge to be the essential bits. So I hope that you find it informative and entertaining. Hey, and welcome to this video. I haven't bought any vintage gear in quite a long time. And the reason is that, well, I'm going to explain the reason right now. Well, a few weeks ago, I was contacted on Nextdoor from somebody who said they had an old NAD receiver available. And we negotiated a price, which was very reasonable, $75. And the woman said that it belonged to her father, and that she thinks it works because she plugged it in and the lights went on. But I couldn't test it. They didn't have any gear at home to test it on. So for $75, I took the chance. Anyway, I brought it home, plugged it in. It does not work at all. Now, this is a NAD 7060 receiver from 1978. It's one of their first products they ever made. 60 watts per channel, AM, FM. Now NAD didn't, this is 78, but they never did like the silver face look. So they always went for this kind of like, I don't know how to describe this, gunmetal gray or something. I believe these were designed in England or this country and built in Asia. I think this one says built in Taiwan or something. But it should be quite nice. Anyway, I'm going to bring it up to my guy Jim. He's my local electronics tech guy, and he's going to have a look at it, and we're going to shoot a video of him opening it up and seeing if he can diagnose the problem. All right, here it is in my back seat. This is a receiver I picked up. I powered it on and nothing happens. The lights go on, it makes a little bit of a hum. I can hear a little bit of hum from the transformer. Just some couple lights go on these meters, but that's about it. So, what's the first thing you do? Hey Jim, what's the first thing you do when you get a piece of electronics in?
The first thing I do is demand money from you.
Oh yes, okay.
Well, I don't know. It's different on different ones, but on this one, being that you've already had it plugged in, I don't have to worry about bringing it up slowly because it's been sitting for a long time.
Yeah, it didn't explode.
Where's this place at? Video van.
I know. I guess the original owner bought it up in Massachusetts.
Yeah. Or is that a service?
Who knows? Maybe it was serviced at some point in his life.
I plugged it in. Step one. I'm not going to put it on an isolation transformer. I do that occasionally, but I don't always do it. My bench is isolated. So I just wanted to turn it on, see if I can hear. I'm assuming this model has a protect relay.
It does. I opened it up and did
I do not hear it clicking. So it's in protect. So let's do the standard visual inspection.
Yes.
That would be the first.
It's a weird case, isn't it? It's wood and it has kind of a plastic wrap around it.
Yeah.
All right, here we go.
All
I see the relay there.
That would be the relay. That looks like the protect relay. I see some brown glue around here that I don't like. When that glue turns dark brown like that, it can start to conduct. That's not in a circuit that would probably send it into protect, but the glue still needs to be removed. Because, I don't know what it was, but back then they put glue on a lot of stuff to hold down vibration and stuff, and then that glue got really old and it actually would start conducting and making shorts. So, your outputs, a little rusty up there.
Yep.
Rust doesn't really affect performance. So, original capacitors, everything looks original. Let's take the bottom off.
Oh, all right.
Do you want to pause again while we take screws out?
Yeah, we can do it. Here's the bottom.
All right.
All right, we've got some circuit board action going on here.
Uh-oh.
Oh, what do you see?
Fuses soldered to the bottom by somebody in the past.
Oh, they're soldered on.
Yeah, which, I mean, they're functional like that, but I don't like it. I like to keep things nice and neat and original as possible.
Wow.
I see somebody jumped bridges on the bottom of the protect relay. That's what that looks like. That is, right? That's the yes, that's the protect relay. So somebody jumped out the protect relay, which means that if you hooked up speakers to it and it were DC, it'd probably fry your speakers.
Ah.
Let's check these fuses out of curiosity. This one's open. And this one's open. So both of these fuses are blown.
That would explain.
That would explain no output. And somebody jumping out your relay, not a good sign. It would appear, I mean, it's possible that the factory glued those fuses on the bottom because it's really kind of a spaghetti nest in here. And I don't see, I mean, I still don't believe the factory did that, but I can't see why the person who soldered those fuses on, that might be factory, because I don't see why it doesn't look like they removed the fuse holders. There's cutouts for them on the board, but there's no fuse holders there. So either this actually is factory, and back then the factory could do some weird things.
So basically you have to change out the fuse. You have to unsolder the old fuses and put new ones in, right?
Right. It's hard to imagine. Well, we have to find out why the fuse is blue.
Right.
There's a lot of this kind of stuff. Long traces of solder. I mean, that could be factory. Yeah, it's hard to say, but it doesn't look like anybody actually... It's hard to imagine that the factory would solder fuses on like that, but especially them being this close to the metal cover on the bottom. But anything was possible back then. Factories did things online to try to make corrections. They didn't, design everything with things like AutoCAD back then.
So you found a few issues, right?
Yes.
That are red flags, perhaps.
Well, the jumping out of the relay is
that the number one red flag?
That's the number one red flag. The fuse is soldered to the bottom. I can't say definitively that...
Well, you know why they blew.
I can't say why they blew yet, but I can't say definitively that there were fuse holders on this side of the board, but there are cutouts. So I'll have to look at some pictures on the manual. So I'm just going to do a quick check of the output transistors and see if they re-shorted. Which these two don't read dead shorted. I can't get to the bottom one on this one, but I can check the top one. just to see if I can immediately locate a dead short. Well, so far, no dead shorts there. So, let's go across the two main capacitors. First, let's unplug it.
Good idea.
Yeah. And let's check to see if there's any voltage on those capacitors. There is no voltage. So, let's check.
What does that mean?
Well, capacitors store electricity, so if power got to those capacitors, they'd probably have some charge. Now I'm just looking to see if it reads a short across either one of these capacitors, which would indicate that one of the B plus lines, the positive or the negative, is shorted. And there's no shorts across the capacitors. There doesn't appear to be any short from the fuses to ground, but both fuses are open. So let's plug this sucker back in, and let's just see if there's any voltage on one side of these fuses. There's some AC on both fuses. There is AC, so these come off a transformer. I think, it's at a time when we need to download a schematic for it and take a look at because we don't know what the value of those fuses are. I'm not going to trust that those fuses are the right value. It's kind of interesting that the fuse is blue, but there doesn't seem to be an immediate apparent short. And for both fuses to be blown, let's see what those fuses do, where they are in the circuit. It looks like they take voltage from this transformer, and then it needs to be rectified someplace. There's some rectifiers back in here. But it needs to, that AC needs to be rectified and then sent to these capacitors. So I think it's time to stop filming for a few minutes while we open up a schematic.
Okay.
If you look right there, I don't see fuses. So the factory may have actually soldered those fuses to the bottom. Because I don't see one there. And that's exactly where that is. See the space?
Mm-hmm.
It's the same as that space. So I don't see fuses there. So the factory may have actually done that. It would appear that way. And according to this, so you got minus and positive 23 volt rails. And then you've got a fuse here. Is there a fuse on the back of this? Because I saw a picture of, look at this. That's the foam that they put in these things that deteriorates over time. Yes, here's a fuse. And this fuse is obviously good because it lights up, and it wouldn't even light up if that fuse were bad. But let's look at it and see if it's the correct value. Calls for a 4 amp fuse. And this is a 4 amp fuse. That's good. We always confirm that fuses and things like that are the right value because people do things.
Yes, they do. I've even done it. I've said, well, it's close enough.
Yeah.
I don't have the exact value.
So that's this fuse, and I'm so far not seeing other fuses in the power supply. So those fuses. So it's interesting that those capacitors didn't have any charge on them, but it doesn't look like there's any fuses.
The big ones, you mean?
Yeah. It doesn't look, I mean, I don't think those capacitors have built-in resistors to drain the voltage, but let's try it out of curiosity. Let's see if there's power on those capacitors. While it's actually turned on. This is a long process.
Yes.
No voltage. All right, so there's no voltage on those. So all of this stuff.
What does that tell you?
Well, it tells me that no voltage is getting there.
Yes.
And so
Therefore,
if it's lighting up at all, then the main fuse is good, but for some reason there's no power getting to those capacitors. So now I'm going to try to find those. So, and then you've got minus 41 and positive 41. That's probably the rail voltage for the outputs. So that's those two fuses. They should both be 4 amp fuses. It's not the easiest schematic to read. Some of these this schematic is a little not well copied.
a little fuzzy.
Yeah, so this is a 12,000 microfarad at 50 volt capacitors, these two.
Mm-hmm. You think they might be bad?
Well, they're old.
Well, yeah.
But
Like 47 years old.
Yeah, they might still
46 years old.
Yeah. Not as old as you, Dave,
Nope.
but few things in this world are.
That's true. And you're even older than me, so what does that tell you?
Well,
Smart
age,
guy.
Some people think that with age you become wiser.
I've heard
But we
that.
know that's not true.
That's true.
I'm the same old butthead I always was. I'm just older.
That's true. You're just an older butthead.
I'm an older butthead.
No wisdom is pierced that dome of yours.
Yeah, I mean, it's come, but I've let it go already.
It's right out again. I don't need that.
What has it done for me?
Exactly.
To be wise.
Exactly.
Well, it's not the most fun unit to work on.
Why is that?
Well, I mean, aside from the jumping out of the relay, it's also the schematic is bad, it's poor. These units sounded really good and they were designed really nice from an electronic standpoint, but from a mechanical standpoint, they were difficult to work on, difficult to follow. And so unless you're really familiar with this unit and you've worked on many of them in the past, it's going to be time consuming to spend any time troubleshooting it.
And expensive.
It could be expensive. But to an audiophile like you, Dave, cost is irrelevant.
It's no object. I'm not an audiophile. I'm an enthusiast.
You're an audio enthusiast.
Yes,
and to an enthusiast, cost is not an inhibitor.
Unfortunately, that has been the case in the past. Yes, you're right.
Because you're just motivated by getting old gear running.
That's happened in the past. That's true. Now, as we know, sometimes restoring old gear is not cost effective. It's just not really worth investing that money into because it's never going to be worth what, all the expenses. If you tried to resell it, you would lose money on it. So sometimes it's not worth it. I think this might be worth fixing.
But I'm just trying to sort of get my bearings of where the transformer wires go. They all go over here. And then you got those two rectifiers, D802. Let's see if we can find that in the schematic. That'd be fun. And I'm not seeing any voltage there. No DC voltage there. That's pretty interesting. That means that there's no power getting to this transformer. But the lamps are coming on. There's something weird going on here, Dave.
Not surprising.
All right. So there's no AC voltage coming out of this transformer and getting to where we need to get it. Just a visual inspection of these fuses. There was no voltage on either side of those. There's some jumper going on here too. Yeah, they shorted out like all 3 terminals. There's a blank terminal there that wasn't used, and then there's these two, and they jumped out all of them. It's interesting.
Are we assuming the relay is okay? Or is that bad?
Well, the relay is probably good. I mean, it's an old relay, so are the contacts a little burned, and should it probably be replaced? Maybe, but we can decide that after we actually get this beast working. Well, this is not going as quickly and as easily as I'm sure you would like to see it go. Yeah, there's power there. Power there. So I'm assuming there must be power. Yep, there's 100. You gotta be careful. Wow. There's 120 volts across this terminal strip. So you can accidentally touch that while you're working on it.
Yikes.
That's pretty kind of sketchy unit, Dave. Put fuses on the bottom, you know, that's how they did things back then.
Careful.
So out of the transformer are 2 blue wires, 2 orange wires, a black wire, you know.
Quite a few wires.
Quite a few wires. It's going to be a matter of physically tracing these wires and trying to figure out why the AC is being lost that's supposed to feed this circuit. It doesn't check a short. And it's pretty difficult to trace out because it just goes all over the place, doesn't it? This is either a mistake, which happened back then too. We don't have privy to things like old service bulletins that came out on a lot of these old units. Sometimes you find them, but not that often. So without seeing some service bulletin that said, oops, we made this mistake, make a correction, we don't know. I don't believe that the different input voltages for European would change the output voltages. I think the unit has to run on 41 volts, rail voltage. It's hard to read these numbers. Cathode of 803 and the cathode of 801 should be AC voltage coming off the transformer. Let's see if we can locate that. The 2 cathodes, 801 and 803. So across these 2 cathodes, which is very difficult to access from the top, and very difficult from the bottom too to figure out which is which. So I'm snipping this. We're gonna snipping this wire tie. It's not plugged in. We're gonna snip this wire tie just so we can move some of these wires around a little bit more. It's not always the easiest, simplest thing to work on these.
I assumed it was easy. It was a piece of cake. That's what I've always assumed.
That a real technician just goes in and fixes it.
Right.
Yeah, that's how it works.
I just reckoned that was how, 1, 2, 3, fixed.
Well, this is a little sketchy because we don't want to short out the AC. This wire is almost ready to break. Because somebody's had this out and was checking this in the past. So somebody was going down the same path in the past that we're going down. But here I've got going into this transformer actually 3 wires, even though the schematic that I'm looking at shows 2. But I'm going to assume, so there's a white wire, and then there's this brown wire. So there is 120 volts. I'm going to clip this out of my way too. There is 120 volts going into this transformer. Let's do a continuity check and see if the primary side of the transformer is got continuity. It's unplugged. It does appear to have, it does have continuity. 1.6 ohms is probably about right. Which means the output of this transformer, it would be pretty odd for the output to be open. And it's got a ground wire going into that transformer, which is kind of odd because it doesn't show it in the schematic. But so coming out of this transformer, we got 2 blue, 2 orange, and a black. All right, we're gonna have to start. We gotta cut more.
Snip, snip.
Snip, snip. We have to know where the wires go. Because there may be as simple as just an open connection someplace. But we have to know, because so many orange wires.
Yeah, maybe they had like a surplus of orange wire at the factory.
Yeah,
Use the orange wire.
right. The engineer's uncle owned a wire factory.
Right, we made too much orange wire. You got to use it up.
Yeah. Would have been nice if it was a little color coded to trace things, but so this is this orange wire, and it goes here, and it goes right to that post, to the fuse. The power transformer wires go to those fuses.
Oh,
So let's do an interesting test here.
okay.
Let's plug this mother in. Let's go to AC. Let's plug this sucker in. Let's make sure the power switch is turned on, right? You see the pilot lights lighting? Yes. Okay. And let's go across the back side of these 2 fuses and see if we have AC. Look at that. We have 67.8 volts coming out of that transformer. That's a good sign, Dave. The schematic sucks. So we're gonna have to start by replacing these fuses. 4 amp. You know,
You got any 4 amp fuses in this place?
I have unbelievable fuses. I bought fuses back in my 40s, and
So-
I'm in my 60s now, and I'm still using those fuses.
Lifetime supply of fuses.
AGC4. AGC does not have pigtails. That's not that important, but you overheat fuses without pigtails and you can screw them up. We got a lot of those. GJV are the pigtails.
Wow,
Do we have GJV4s?
Hope so. All those fuses you got. You assume you got 1.
AGC GJV3s, pigtails, little wires coming off the fuses. So these do not have little wires. I don't think I have 4 amp pigtails, so that's okay. We'll use the 4 amp fuses that we have. Then we're gonna need the Variac.
Yes.
Now see, these don't have pigtails. Makes them a little more difficult to unsolder. Let's turn this up.
Turn on your soldering iron.
You're doing a lot of filming, Dave.
I am.
You're gonna do a lot of editing,
I'm
that
gonna do
means.
a lot of editing.
In the summer, because I live in Florida, I like wearing shorts. But
But
you drip solder
yes,
on a naked leg,
it's gonna hurt.
and you know the mistake that you've made the minute you make it.
Yes, it's like frying bacon and naked.
It'll wake you up in the afternoon.
Yeah, you should wear an apron.
I could wear an apron. That's true. It's not as much fun as accidentally forgetting and dripping solder on your leg.
How often has that happened?
It's happened maybe twice in the last 4 years. Look at this. We're dripping solder
You're
everywhere.
making a mess.
That's because somebody put an excessive amount of solder on here. It's all right. We'll clean this all up. So these were originally pigtail fuses.
All right. So they were supposed to be soldered in. We're assuming that's factory now.
We're
aren't we?
assuming that's factory. Solder sucker.
That's right. One of your favorite tools.
I still like my solder wick. But all that old solder.
Wow.
I still like leaded solder, although it's probably over the years made me stupid to work with lead.
Yeah, you probably
probably
just killed a few brain cells.
probably part of my overall mental illness. So you got to
So
really
you are making your own pigtails.
Yes.
You're putting your own pigtails.
Why am I doing that? Because I don't have any with pigtails.
You have to make your own.
I have to make my own. Alright, that one has pigtails now.
Look at that. Alright, Mr. Pigtail.
We have pigtails.
There we go.
Now, we're just going to temporarily tack this on because we're going to assume there's a reason why these fuses blew. I'm going to check these diodes actually before we actually do this. We will check this diode. Checks good. This diode. Checks good. This diode. So let's see if we can just temporarily tack these on, because rectifiers check okay. We may be in luck here. But what made these fuses blow? Power surge maybe? We all want a better angle. Now, of course, I'm not going to be able to put the bottom cover on with these fuses sticking up like this, but this is just a temporary thing just to see if this is going to fire up now. And then if it does fire up, we're going to have to make sure that there's no DC getting to the speaker terminals. This is, we're here. We're at this place in time where we're going to get out the Variac.
All right.
It had a voltmeter on it that I got rid of, and I put an ammeter instead so that I can see if it starts drawing current as I'm turning it up. Damn thing.
What's going on there?
These things are spread too far apart. All right, so we power it up. Now we can bring the voltage up slowly. And this thing will start vibrating if it's drawing too much current. It'll start humming. Yeah, this thing's already vibrating.
What does that mean?
Ammeter doesn't seem to be working right lately, but that generally means that it's drawing too much current, and that would explain
Blowing the fuses.
blowing the fuses. But if the outputs don't check shorted, now these capacitors have gotten voltage on them. See how they're still charged up a little bit? Aha, well there's the difference. Let's bring this up, power up just a little bit, right? And we'll check this. So we've got 6 volts. And this, we've got 6 volts. We like that. So we've got 8 volts and negative 8 volts so far. And we're at about 55 volts AC. I'm smelling. You can use every
sense.
You can smell, you can see.
Not touch.
You don't generally want to touch too much. There's too much heat. Like these are wicked hot already. These are cold. These are hot.
What are those?
Those are emitter resistors. So for these emitter resistors to be that hot with that little voltage, there has to be a shorted output. Or there's a short somewhere in those output circuits. These are cold, which is generally a good sign. These, see, I could smell the heat coming off of these. I've got an acute sense of smell.
Yes.
And you want to touch those, Dave? Touch them.
Oh, Thanks.
Now
Thanks
touch
for the
now
warning.
touch these.
Thanks for the warning. Thanks for the warning. They're hot. You're very funny.
That was pretty entertaining, I have to admit. So I would say that these wires are going to be going to this. See this orange, red, white, and blue. Look at that. Red, white, and blue. And now you got red, white, and blue over here for the other channel going up to these output transistors.
So I say something wrong with the transistors?
That's what I would think. So now this going to these back transistors. Remember I couldn't check the bottom one because of where it's physically located. But my guess is that if I was to go across these three terminals, they check like diodes. They don't check shorted. Huh. But there's obviously something going on here. So, I mean, there could be a driver transistor or something shorted, but I doubt it. There has to be a short up here someplace. One would think, right? Now that we disconnected that, let's try bringing it up again on the Variac. So you can touch these now, they're not that hot.
I'm not going to touch them again.
Off.
Are they hot?
Yes, they are. So those, you know, without looking at the schematic, I don't really know what those wires even did. But those are obviously not the power wires. So you got this blue wire, and then you got these bigger wires. These come. This is a pain in the ass, Dave.
Yeah. I'm coming to that conclusion.
I can't get to the bottom.
Is the power coming up from underneath?
No, it's coming from all these bigger wires.
Oh, down there.
Yeah.
Inside there. That's where the power is coming from.
Yeah.
Not these ones on top.
Right.
All right. You think these transistors might be bad?
At least one of them, it seems like. How do we get this heat sink off? How do we get access to it? Oh, man. They got these bolts, I guess.
Wow, that's a long screw.
Yeah.
Or bolt.
Yeah. Now this one. Always needs service. Like dusty old people. 2SB and 2SD. Let's, are they the same as the ones, as the other ones? Are they originals?
Who knows?
Not much wire here to play with, is there? 2SD and 2SB. Yeah, they look like originals. NECs. Those were good transistors. That check shorted.
What does?
I thought I checked that before, but that's shorted. This top transistor
Oh.
is shorted.
The top one here is bad.
Yep.
So you think that top one is bad? That's causing the problem.
It is.
Do you have those in stock?
I don't know. I might have some substitute. 2SB 539. I have a lot of outputs, but you know, getting this sucker, I'm gonna have to. I don't really want to move that because it's gonna be easier to put it back together if I don't have to move that. Let's snip.
Snipping.
Yeah. So we really don't want to do that. So we're gonna have to loosen this up. We didn't really want to, but we're gonna have to because we need access. So. Alright, so look at this stupid thing. So now we have to unsolder this top one. Of course, you know, the way they built this, they're not sockets that you can just unscrew and push them in. You have to actually take these nuts off. You have to disconnect all the wires. It's kind of a pain in the ass. That's how they did it, Dave. They did it on purpose. You know why?
To mess with you.
To mess with us. We used to think that. We used to think, Japan was getting even with us from the war.
This is Taiwan.
They made these in Taiwan?
Yeah.
Oh, man. One of the things you have to be extremely careful of when you're playing around with stereos like this, the one thing I have never done, I hope to never do.
Electrocute yourself.
No. That I've done. But you never want to drip solder on the dial cord or touch it with your soldering tip.
No, that'd be bad.
Because the minute it breaks, you have to figure out how many turns it goes around here, how to get it all through these pulleys.
I've heard horrible things about tuning. Yeah, those trying to mess with those things.
I have fixed a few of those. I've redone some of those, but they're difficult.
For what? And for what? Who listens to radio anyway?
I do. So the other transistor appears to check good. All right, so we got that off. We get this off. Let's clean this up a little bit more. See if we can solder suck it.
My wife always warns me if we go out. She says,
"Don't talk."
Yeah, don't. Careful what you say.
Husbands should be seen and not heard.
Right.
Is that
Don't annoy anyone. I was like, I don't annoy people. I don't know where she's getting this from.
She's getting that from her own personal experience.
I think when I first met her, I was in my early 30s, right? And maybe I was a little arrogant and full of myself, at that age. But I've definitely
You've grown.
I've grown a lot.
You've decided that
I'm much more humble, and I know how to, I'm much more careful about what I say. I don't have those. I definitely don't have the same kind of
rapport.
I don't
attitude.
Yeah, I don't act like that anymore. And but she still remembers, I think. So she just reminds me not to.
That's what wives are supposed to do.
But she loves to remember stuff from 30 years ago.
No, I married my wife because I thought to myself, I got married in my 50s, so I was old. And all those years, I kept thinking to myself, I really need somebody that can notice when I'm wrong about things and point it out.
Yes.
Because I would hate to go through life being wrong a lot and nobody pointing it out.
Right.
She's
very quick to point it out.
She was perfect for that.
Yeah. Oh, it came right out.
We got it out. It was like extracting a tooth.
Dude, is there any compound on the bottom of those things that they put on?
There
those?
is.
Or mica.
There is a mica insulator and some heat zinc compound. It's not the white stuff. There was white stuff and there was clear stuff.
Silver.
The clear stuff is the same stuff, silicone. Right. It's the same stuff that they used for spark plug boot release.
Yeah.
The silicone. And so you can use that. I like it better because it doesn't get white stuff all over the place. But I generally use silicone pads. They're cheap enough now. Okay. They're better. So let's check this completely out of circuit.
It's out of circuit now, I believe.
Yes. Let's check it and see that it still reads shorted. And you know it will. Look at that. Shorted and not shorted. So it's got I believe that's going to be collector to emitter short. The casing is always the collector on these. So yes, this has a base to collector short.
Ah.
Base to emitter actually does not check shorted.
Oh.
So it's got a base to collector short. So this sucker is bad in technical terms.
Yes.
2SB 539B. That's sucker bad.
So this is your box of transistors.
539B, and see what substitute NTE comes up. It says that it's a 285, their substitute. Okay, now let's do a 2SB 554. So they're probably close. Now I would have to actually look at the specifications.
So there might be close.
It might be a good enough sub. As long as the one that we want to put in there is rated for slightly more current or slightly higher speed switching, it'll be fine. This is 15 amp. Emitter to collector voltage is important, 180. Emitter to collector voltage, 140. You could use this one for this one, but not this one for this one. So that's not a good substitute. So we may just order the right one. Well, I'll tell you what, we'll wrap it up.
All right.
This is what I need to sub out. We'll work on getting a substitute for that, putting it in, putting the fuses where they belong, see if we can get this sucker fired up.
All right. So
And
we
then-
did some major troubleshooting here,
Major troubleshooting.
and that was quite something, which you had to go through just to figure out what was wrong with it.
I have to take a nap now because my brain is.
Me too.
Tired.
You better eat some. You better eat some lunch. All right. So you're just going to close it up, put it on the shelf, order it apart, and then one of these days you'll get to it.
Well, I'm gonna wrap this up pretty quick now.
Oh, okay.
But now I have to take your name, your phone number, write up paperwork,
Oh yeah.
the whole not tag it with one of my tags.
Oh no. One of your horrible.
I know you don't like my tags
One of
because
the
they
horrible
stick very,
stickers.
but that's
I
what
know.
they're supposed to do.
I know. I need a
I
hair
can't
dryer.
have a bunch of stereos on shelves. And you see all those stereos in there, Dave?
Yeah. Where are they? In here?
In there. All those stereos, I can't have tags falling off them, and
That's
then I
true.
don't know who they belong
Yeah.
to.
Yeah. You got a lot in here. Look at all this. Who knows? It's hard to tell what they are from the back.
Yeah. Some of it's junkier than other stuff.
You've got quite a turntables.
Turntables.
This is all turntables, pretty
A
much.
lot of
over here.
turntables.
You got some old.
There's a Raku cut. You ever see a Raku cut
Oh yeah,
turntable?
yeah. Where?
Right
Up there.
there.
Oh
That's a
yeah.
Raku cut.
Rakuka. Yeah. It's like.
And the one above it is a NAD.
Oh yeah.
Flat tone arm.
I remember those. Yeah.
You know?
And then you got lamps
Yeah.
and old
toasters.
toasters and clocks.
I'll do some of
Some
those.
old
I'm
vintage
starting to back
speakers.
off doing that stuff because I'm so
There's a
busy
clock.
with stereos.
Yeah. What do you got over there? Some more stuff. Guitar amp.
Those are just spare speakers.
Guitar amp.
Guitar amp. Look at this baby.
What is
Who
that?
wants it besides nobody?
Oh, an old reel to reel.
An old Sony reel-to-reel, but it's in pretty good condition, so.
Some guys refuse to work on reel to reels. You won't, but some people will not.
Well,
work
that's
on
because you need
reel-to-reel.
specialized tools.
Now here's an update. Later that day, Jim called me to say that he did find a compatible power transistor in the shop for the NAD, and that he should have the receiver up and running this week. So that's great news. And after I get it back, I will make a follow-up video about it in the coming weeks. Now, thanks for watching this lengthy video to the end, and please let me know if you'd like to see more like it in the future. And please do all that like and subscribe stuff. It helps this channel get noticed. If you'd like to contact Jim, Google Nice Find Fix-It Shop in St. Augustine, Florida for his address and contact details.